Assalamu alaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. So children, we are going to continue with the lines and angles chapter. Okay, so here we are going to learn, today we are going to learn about parallel lines and transversal. Okay, so you have heard about this parallel line, right? Parallel lines are the lines which are which never meet each other, right? The distance between the two lines will be the same everywhere. You look how much ever you extend these two lines like M and N, if you keep on extending on both the sides, it is never going to intersect each other. Okay, these are called as parallel lines. And if there is a line which intersects both these lines, like line L, see, you see M and N are parallel. Okay, and usually how do we denote this parallel lines? Like in figure, if you want to show, you will just put an arrow like this and show it. Okay, this says that these two lines are parallel. Okay, and if there is a line which intersects these two lines, then that line is called as transversal. Okay, so here line L is the transversal. So when you have this kind of a setup, that two parallel lines intersected by a transversal L like this, you are actually getting few angles. See, you are getting angle 1, 2, 3, 4, 5, 6, 7, 8, right? You are getting 8 angles. So now if you look at it, so there are few names given to these, there are terms given to these angles. The angle 1 and angle 5. See, look at it, angle 1 over here and angle 5 over here. So what can you tell about these two angles? These two angles lie above the parallel lines, right? 1 lies above M, 5 lies above N, and they both also lie to the left of transversal, right? So they both have a similar view, right? So these two angles are called as corresponding angles. Okay, so we have more such corresponding angles, like I'll show you with a different pen. See, angle 2 and angle 6 look the same, lying above the lines and to the right of the transversal. So 2 and 6 are corresponding angles. Okay, similarly you have 4 and 8, right? They both lie below the lines M and N and to the left. And similarly 3 and 7. So there are 4 sets of corresponding angles. Okay, and in case of parallel lines, these 4 sets of corresponding angles, like this 1 and 5 will be equal to each other. See, angle 1 and angle 5 will be equal. Angle 2 and angle 6 will be equal to each other. Angle 4 and angle 8 will be equal to each other, and angles 3 and 7 will be equal to each other. Okay, so corresponding angles are equal in parallel lines. Okay, they are equal. I'll write equal here. Now come to alternate interior angles. So first, what do you mean by alternate interior angles? So I will use the pen color now. Wait a minute, let me remove these colors which I have marked now. Okay, yeah, so here this is they are equal. Yeah, when I come to alternate interior angles, alternate means it's cross, right? It's opposite, isn't it? So opposite interior angles. So among this, the interior angles are 4, 3, 6 and 5. These are the angles which are lying within the line, right? Inside the line. If I say M and N, see, they lie between M and N. So these 4, 3, 6 and 5 are interior angles, but they are talking about alternate interior angles. So it's 4 and 6 form an alternate interior angle, and the other set is 3 and 5. Okay, and they are also equal to each other. Angle 3 and angle 5 will be equal to each other, and angle 4 and angle 6 will be equal to each other. Okay, so they are also equal to each other, and this is what you mean by alternate interior angles. Okay, now similarly I will say what is exterior angles. So when I talk about exterior angles, it's the angle outside the M and N. So those are 1, 2, 7 and 8 are lying outside the angle N, and so we have to find out alternate exterior angles. So again it's going to be the cross. So 1 and 7 and 2 and 8, correct? So 1 and 7 will be equal to each other, and 2 and 8 will be equals to each other. Okay, they are also equal to each other. So this happens only in parallel lines, not in any other lines. Okay, all right. So now come to interior angles on the same side of the transversal. So interior angles on the same side. So interior angle we know it's 4, 3, 6, 5. So alternate means it's the opposite we took. On the same side is going to be 4 and 5. So in this case I can take 4 and 5 are on the same side and 3 and 6 are on the same side. Okay. Alright, now here you see I've written inside this box. I have written, say these are corresponding angles, all these things which are equals to each other. Just now we have learned, that has been summarized. Okay, now interior angles on the same side of the transversal are also referred to as consecutive interior angles. So these angles, the angle 4 and 5 and 3 and 6, what I told, it's also called as consecutive interior angles. Okay, or allied angles or co-interior angles. So these are the terms used over here. Okay, further, many a times we simply use the word alternate angles for alternate interior angles. So for alternate interior angles we just use alternate angles. Okay, most of the cases we don't say that interior word. Okay, so just telling you how it is called, because you should not get confused if you see this kind of words in your test. Okay, now we have few rules, few theorems and axioms from this, whatever we have learnt based on this parallel line. See, you have to write everything, all these things in your classwork, children. That is your geometry notebook. Okay, alright, so these notes have to be written. So axiom 3.3 says that if a transversal intersects two parallel lines, then each pair of corresponding angles are equal. Just now I told you, if it's a parallel line, then the corresponding angles are equal. So that's what they're saying. Okay, and if the transversal intersects two lines such that the pair of corresponding angle is equal, then the two lines are parallel to each other. So it's the other way around. So I told you that if it's a parallel line, then the corresponding angles are equal. Similarly, if the corresponding angles are equal, then the lines are parallel. Okay, it's the reverse of each other. Okay, converse of each other. Okay, now coming to the next theorem. If a transversal intersects two parallel lines, then each pair of alternate interior angles are equal. So the same thing. Okay, as I told you, the alternate interior angles in case of parallel lines are equal. That's what is written. And similarly, if the transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. Now this point, exercise point 3.4, theorem 3.4 says that, see, we know what are the sides on the same side of angles on the same side of transversal are 4, 5 and the other one is 3 and 6, right? So what 3.4 says is that angle 4 and angle 5, if you add them, they will always add up to 180. That's what they mean by supplementary. And angle 3 and the other angle, what's the other angle? Angle 6, right? So these two added together will give you 180. Okay, so that's what it says. It's supplementary. Now similarly, the converse of this is going to be if a transversal intersects two lines such that the pair of interior angles on the same side of the transversal is supplementary. So what it means by supplementary is when you add them, it should give you 180 degree. Okay, then the two lines are parallel. Okay, you would have heard this word complementary also. The complementary is nothing but when you add the two angles, it should give you 90 degree. Okay, but here it says it's supplementary, so it should add up and give you 180 degrees. Okay, so now we'll look at the other theorem. Lines which are parallel to the same line are parallel to each other. That is, if you have two lines, let us say there is line A, there is line B, and there is line C also somewhere over here. And if I say that A is parallel to B, okay, and A is parallel to C also, then C and B are also parallel to each other. That's what it says. Okay, if A is parallel to B and if A is parallel to C, then B and C are parallel to each other. Understood? So that is what this theorem 3.6 says. Now coming to exercise 3.2. It says in figure, so I have done few questions, okay, just few questions for you, and you can just understand it and you get an idea how to solve the problems. I expect you people to complete the whole exercise in your geometry classwork. Okay, so I want you all to write the notes so far, whatever I have written over here, plus the exercise 3.2. Okay, so in figure 3.28, this is figure 3.28, find the values of x and y. They are saying this x and this y, they have given you in the diagram. It's very clear. And then there's also, and you have to show that AB and CD are parallel. Okay, so if angle, this thing is 50, okay, this is 50, then what will okay, so here these two angles form a linear pair, right? They lie on the same line, correct? They lie on the same line. So if there is a line, it's going to be 180 degree. The whole in a line always it's going to be 180 degree. And if you have a angle like this, so this and this added together, this and this added together will also give you 180 degree. So you can either find the x by subtracting, see, 50 plus x should give you 180 degrees. So x is equals to 180 minus 50, which is 130. Okay, so you're getting 130. Or what you can do is, see, always when you have a angle like this, line like this, and the cross angles, these are called as vertically opposite angles, and they are always equal. Okay, so if you go by that method also, you can say that this y is 130, because see, 130, this is 130, so this will be 130, right? Or you can just find the x like this, how I did, and I get 130 over here, and x and y are alternate interior angles, right? So they both are equal to each other, and that's what you're getting, right? You can either find this one and then say that x is 130 because alternate interior angles, or you say x is 130. Okay, yeah, we have to prove that they are parallel. They haven't told us that it's parallel, right? So you separately find out. Okay, this x you find it out as 130 degree, and here y is equals to 130 degree, and the reason is vertically opposite angles, right? So since your x and y form the alternate interior angles in this case, and alternate interior angles are equal, then therefore AB is parallel to CD. So you will write that x is equals to y is equals to 130 degree, and these form alternate interior angles. Okay, and if alternate interior angles are equal, then AB is parallel to CD. So therefore AB is parallel to CD. Okay, so now they will come to this problem. So this is little different. Okay, here they are saying that AB is parallel to CD. Okay, there are three parallel lines. See, AB is parallel to CD and CD is parallel to EF. So according to theorem 3.6, all the sides are parallel to each other. Okay, all the lines are parallel to each other. Now they are saying y and x. Okay, y is to z. See, when you see this is to, that means it's y divided by z. Okay, y divided by z. Okay, y divided by z is equals to 3 by 7. Okay, y is to z is equals to 3 is to 7. So you can write it as y by z is equals to 3 over 7. Okay, now but then they are asking us to find x, isn't it? Now, but they haven't given us y and z value. Y is not 3 and z is not 7. The ratio is 3 and 7. This means, it was some number. After division, it has become, 3 by 7. It could be any number. We don't know what got cancelled. So we will say that let the common term be a. There was some number attached to the 3 and 7, which got cancelled. Like for example, let me say you had 6 by 14. So when you divide it, you get 3 by 7, right? 2 3s are, 2 7s are. So here what was common? 2 was common. If I say 9 by 21, again here if you will get 3 3s are 9, 3 7s are. So here the common term was 3. So we like that something else was there. After cancelling that common thing, you have ended up getting 3 by 7. So we don't know what is that common term. So first we will try to find out that common term. Okay, so what for that we just assume the common term to be a. So it has to be 3 into a and 7 into a. Now we know that 3, see, y and this y will be equals to this y, right? They are vertically opposite angles, isn't it? This is y, whatever angle is over here, the same thing you will get over here also, right? So this y and z added together, I told you, right, it's going to be supplementary. So y plus z, they lie on the same side of transversal, interior angles on the same side of the transversal. So y plus z is 180. So y is 3a we have taken, and z is 7a. We will not take 3 and 7, we will take 3a and 7a. Okay, so that gives you 180. So 3a plus 7a is 10a is equals to 180, or you get a is equals to 180 by 10. The zeros get cancelled and you simply get 18. So now what is your y? Your y is 3a, right? This is what it says. Y is 3a and z is 7a. So y is equals to 3 into 18, which is 54. Z is equals to 7 into 18, which is 126. Now we will see what is x. Now here you see, this is z. The same z you will get over here because it's alternate interior angles, right? And if this z and this x are corresponding angles, and in case of parallel line, z and x are equal because it's corresponding angles, right? So whatever we got for z, that will be there for the x also. So that's 126. Okay, this is corresponding angles. All right, now come to question number 3. It says in figure 3.30, if AB is parallel to CD, so these two are parallel to each other. Let me draw an arrow like this, and EF is perpendicular to CD. Perpendicular means it forms a 90 degree over here. Okay, then, and angle GED, angle GED is nothing but this whole thing. So I will just draw using a different pen color. See here, this whole thing is 126. Okay, GED is GED, this one. Okay, so you should know how to read the angle. Okay, and now they are asking you to find angle AGE, GEF, and certain angles are given. So let us go one by one. Okay, angle GED is given as 126. Now they are asking you what is angle AGE. AGE is the angle over here. Now you see, these, if these two are parallel lines, then this angle and this angle will be equal, right? Angle AGE will be equals to angle GED because they are alternate interior angles, right? So angle AGE is actually 126 because GED is given as 126, so AGE is also 126. Now you see, we'll come to angle GEF. So they are asking you what is angle GEF. Let me use a different pen. So angle GEF, this angle is what they are asking you to find, the blue angle over here. Okay, so you know that angle GEF, that is this angle, plus angle FED, that is this angle, gives you 126, right? All these two angles together gives you 126. So angle GEF plus angle FED gives you 126. FED is 90, we already know. So we just say angle GEF is equals to 126 minus 90. So that is equals to 36. Okay, so we get this as 36. So from this whole 126, we have subtracted 90. Now comes next one, FGE. So they are asking you what is FGE. So for that, I will use, let me use a different color. So let us say this one. FGE is this one, right? They want you to find out what is this. So you know that this will be equals to this, right? Because they are alternate interior angles. So how can you find this? See, this whole thing is 180. Which whole thing? From here to here. This whole thing is 180. It's lying on the straight line, no? So you have this part of this is 126. So the remaining is what we need to find out, right? So here angle AGE, that is AGE plus angle GED is 180 degree, right? So you get something like this. This plus this will be 180. Okay, so this is given as 126, so you have to find what is this. So 180 minus 126, that's going to give you 54. Okay, so this is 54. Understood? So this is how, so you have to just apply logic and whatever rules we have learnt, and we are going to solve this, complete this. Okay, now let's so you people finish this exercise 3.2 in your geometry classwork. Okay, do write all the notes plus your exercise. Okay, so that's all for this week today, and see you next week with a different video. Okay, Allah Hafiz. Thank you.